as you probably know, over the last 6 months or more, there's been a political consensus forming around the need to limit global warming to 2 degrees above pre-industrial levels. And for example, there's several references to this now in the negotiating text that will appear in Copenhagen. So what we did in our report was set out to look at both the science and economics of options to let us secure that goal. As you know, as we know from the IPCC fourth assessment report, we're already close to 1 degree above pre-industrial levels, and we're already committed to further warming just from our emissions today. We know from this that to limit global warming to 2 degrees above pre-industrial levels is going to require some strong action to reduce emissions. So what we've done is look at this in detail and look at what targets in 2020 and 2050, global emissions targets, could give us a reasonable chance, which we define as a 50-50 chance of limiting warming to 2 degrees. We did this by generating lots and lots of possible emissions paths, and then working with the Met Office Hadley Centre to look at the climate implications of those paths, so what warming we would expect under different options. So we know from the science that it's now not feasible on any of the currently plausible emissions paths to give a 100% chance of keeping temperatures below 2 degrees. And based on our analysis, it looks like, given where we are now, it would be very difficult to give more than a 50-50% chance of keeping temperatures below 2 degrees. So where we are now, that looks like the best that we could hope for. All of the options that we look at also reduce the chance of high warming of sort of 4 degrees or more to very low levels, so to much, much less than a 5% chance, and a warming of, say, 3 degrees to less than a 10% chance. So what did we find? So we know, to give you some context, that emissions are now at about 47 gigatons of carbon dioxide equivalent above, so that's the level we are today, and they're increasing at 1 or 2 gigatons a year. So we find that by 2020, our emissions would need to be between 40 and 48 gigatons to give us this 50-50 chance of limiting warming to 2 degrees. To put this in context, that's about 8 to 30% above our 1990 levels. And just to note, there's actually a typo in the executive summary. It's 8 to 30% above 1990 levels. So to take the top of this range, first of all, this means that looking just at the science, if we exclude some of the less plausible scenarios that rely on, for example, high aerosol emissions, we would need to stay below 48 gigatons in 2020. And this means that global emissions would need to peak between now and 2020 and start to decline. Looking at the bottom end of this range and various feasibility issues that Alex will discuss, this tells us that 40 gigatons is probably the most we could hope to reduce our emissions to by 2020. So this gives us this target window of 40 to 48 gigatons in 2020. But the shape of this emissions path over time is also crucial. It's the total level of emissions that we emit over time that's the important thing, the cumulative level, not just emissions at one date. And so if we have less ambitious action earlier, so if we delay emissions cuts, this means we'll have to have stronger action in the longer term. So by 2050, we estimate emissions would need to fall to between about 14 and 17 gigatons in 2050. So that's less than half of 1990 levels by 2050. And if we're at the top end of our 2020 range, so 48 gigatons, for example, in 2020, we need to be at the bottom end in 2050, so 14 gigatons, and vice versa. So if we were at the bottom end 40, it would mean going down to about 17 in 2050. It's this balance over time of your emissions reductions that's important. So finally, what does this mean in terms of levels of greenhouse gases in the atmosphere? So today we're at roughly 435 parts per million of carbon dioxide equivalent in the atmosphere, and rising at 2.5 parts per million a year. So to give a reasonable chance, there's 50-50 chance of limiting warming to 2 degrees, and also to reduce the chance of high levels of warming to a very low level, we would need to peak our concentrations at about 500 parts per million, probably within the next 40 years, and then reduce to no more than about 450 parts per million. Now, to put this in context, reminding you of what the Stone Review said in 2006, that review said that greenhouse gas levels would have to be stabilised between 450 and 550 parts per million of CO2 equivalent. So now, today, we're saying that we need more ambitious action than that. We're saying that looking at the science since 2006, so looking at the changes in the climate we've seen and the evidence on future impacts, we'd need to go further than was laid out in the Stone Review in 2006.